Testing sound. Testing sound. Yep. All right then. Well, hello everybody. Things looking good. Going to get right into it today. Though, actually, right. So today we're going to rip out all the stuff I did for scoping, or rather, we're not. Are we? So some of it is useful. Okay. So let me sketch out a few things in my pretend programming language here. Well, not pretend programming language, actual programming language. It is a real, live, honest-to-goodness programming language. It's just a toy. So let's bring up a window to check this out. Oh, you know something? CLion's been bugging me to update. I'm going to switch back to chatting mode, and I'm going to update CLion quick. Partly, I keep CLion on a read-only partition, so updating is not a trivial exercise. Don't have to just click the update button and let it go. There's a little more to it than that. I'm currently using CLion 2025.2.3. All right. Let's go and do this update. One of the things I'm hoping is that maybe the interface with Junie is a little smoother, or maybe it's not quite like its very own thing, and there's also a way to integrate with something else, like perhaps codecs or whatever. Something like that, I'm hoping. So what's right and what's wrong about what I'm doing? So what's right? I do need some kind of nested structure for creating and destroying variables. And in fact, that should be tied to statement lists. Because, like in a while loop, for example, if you have a while loop, then you have a block inside of it. When that block is entered, the variables are created. When the block is left, they're gone. Right? So it makes sense to have a frame for those variables. But that frame is not the same as the frame that will be used for static scoping. Now, since I don't have functions yet, the distinction is somewhat moot, but it's not non-existent. Oh, that's going to get complicated with something else that I want to do. We're having to do something like register allocation without having registers. And we're going to check for updates again, just to see if there's a new version of the plugins. No, there is not. So now we're going to exit CLion. Mark it as read-only again. Start it again. And switch back to programming. So we're going to create just a, I don't know what a good so many different kinds of files here. And none of them are the right kind of file. Scratch file. I'll call it, I just want it to be text. Just plain old text. There's just not an option for plain old text. Just need a scratch file for typing some text into. Plain text. There we go. Can't call it text, have to call it plain text. Okay. So in my language, suppose I have something like this. And actually, in order for this to be valid, we have to do var I equals 5, then we'll do right? But suppose inside here we do something like we don't have a way to print anything yet, right? So while this loop is executing, first this block is entered every loop iteration. This block is technically kind of left at the end, and this comparison is done. And then the block is re-entered at the top. So this block keeps on flickering into and out of existence as this loop is looping. I mean, the block continues to exist forever, but the runtime data associated with the block pops into existence. So here, J pops into existence. J pops out of existence. J pops into existence. J pops out of existence. And it's even more obvious when you get here. Like, okay, as the loop is executing, you get to this block. And then we say var foo equals j plus I, right? And then foo semicolon, just for something to be there. So this block, foo comes into existence. Foo disappears. I wouldn't be allowed to say down here, this would be an error, because the variable foo doesn't exist after this block exits. That means there is runtime state associated with the block coming into existence. All these variable values have to be stored someplace, and that someplace is the runtime state that comes into existence when this block begins, and it disappears when this block ends. So that construct that I have, where I create a stack frame when the block comes into existence, is correct. I need one. But I don't need that stack frame has absolutely nothing to do with the stack frame has nothing to do with the whole program, with the static scoping, with the variables. The fact that this stack frame comes into existence and then disappears has nothing to do with the fact that I can't reference foo down here. That's keeping track of different things. And if you recall from last time when we were doing our Python, I wish I had that Python now to go show. When we were doing our Python, I had the whole thing where Python would just assign slots to variables, and then it would use those slots. And those slots would be labeled with integers. And so in the actual Python bytecode, instead of referring to a variable name, it just referred to a slot number whenever it wanted to fetch that variable. I need to do something very similar. Keeping track of what variables live in which slots is a thing that happens at parse time, and that's part of static scoping, and that is where, that happens at parse time, and it has nothing to do, I won't say that, it's only peripherally related to the scoping that happens here, where this stack frame pops into and out of existence when this block is executed. So, CLion has this place where it puts scratch files. I have no idea where that is. Like we go here. Is there a file named scratch.txt that got stored someplace? There is not. So this scratch area is some kind of global scratch area. We're going to find it. Well, that's very interesting. So it stores all of these here in the JetBrains config, all of these scratch files. I don't know that I like that. The scratch file is actually unique to this project. So we're going to move it. And we're not going to add it. There. That's where it belongs. It does not belong in that other place where it was being stuck. Alright. Now we have scratch.txt here. find kind of annoyed that it did that. Okay. This means that the parser needs some kind of parser context. Yes, because even the top. Yep, the parser context needs to be passed down. It can't be just returned. Adding this variable declaration is going to make things a lot more complicated. So do I have a top here? Because I was thinking through how to do this. What should go into the context? What is the find? It's Control F. Why can't I do Control F? Oh, I get it. Stupid thing. There. It's JetBrains and its inability to handle focus follows mouse again. Actually, let me do a few things. Trying to get more people interested in watching. see here. So, static scoping. So the reason why I was wanting to look for stuff is I want to see where I said top. Ah, yes, there we go. Top is an alias for parse sequence. So basically it acts like there's a virtual set of braces around everything. And that is encapsulating the sequence. Now, there's an interesting question about implementing functions. If I implement nested functions, then the question, a different question involving the relationship between static scoping and functions comes into play. It has a name. What is closures? Yes, closures, where essentially a pointer to a function also has a pointer to the entire context for that function. Its local variables, the local variables of the place where it's being executed, all kinds of stuff. And closures are complicated to implement, especially if you have a strict stack. Like if you were using assembly language, like if you're compiling direct to assembly language like C does, or C++, or Rust. I don't know how Rust handles closures. Handling closures becomes a huge pain because you have to sort of make a copy of your call stack, because the entire call stack is kind of part of the context of where the function is executing. That function, when it returns, it isn't going to pop that call stack. The entire call stack is going to disappear. But anything within that call stack that the function might reference is part of the function's closure. Like all the variables that the function might reference that are part of the nested set of static scopes in which that function is in are part of that function's context and need to be remembered. C++ handles this in a really bizarre way with lambda expressions, because lambda expressions, you can basically make copies of things into the closure. You can basically decide what gets to be part of the lambda's closure and what doesn't. And under the hood, what that does is it just creates a class, a structure that holds all of that data that the thing might be referring to. I don't know that I want to do that either. GCC implements a weird thing called a trampoline that I'm not completely sure how it works precisely, but they have something like closures because they allow nested functions. But I think they're strictly limited in some way. And for example, if the function that has the nested function exits, I think that the function can't get back its context anymore. That referencing, if you pass a pointer to the inner function out of the function, then that it gets called. Anyway, I'm talking kind of nonsense in a certain way because some people here might not have any clue what I'm talking about at all. Like I'm using concepts that are a little more advanced than we've encountered trying to work with this parser at all. And I'm not explaining them. So, closures. The reason I care about this is because it informs what I'm going to do. If you don't have closures, that means the top level parse thing is special because it's the only place where you can declare functions. But if you do have closures, it stops being special. I think I just will cross that bridge when I come to it. Like, I could sit here paralyzed all day about what to do in this case and how I'm going to implement closures in the future and blah, blah, blah. But I have a test suite. I'm going to, add tests to it so I can test whether my code continues to function as I completely rip it apart and put it back together again in a different way in order to implement a feature I didn't anticipate. So I'm just going to ignore that for now and pretend that functions will only be declared at the top level or something like that. If I add functions to the language at all, which I might not do, I'm not sure what will stop this. But I'm just going to ignore the issue of closures for now. But I'm also going to kind of pretend for now that there is nothing special about the top level, and this is just going to remain parse sequence instead of having a special parse top. But one of the reasons why I made parse top be this thing that's an alias essentially for parse sequence is so that things that called parse top, I could change it so that there was a special top level of your parse tree if I wanted to. Welcome, Tinky Mokle. I'm not sure. Tinky Mokle? Moko 123. Welcome. I hope that you're interested in C++ and how programming languages actually work internally, because that's what we're doing today. So, given that, I have to have a parse context. And this parse context, first I'm going to decide what's going to be in it before I decide what the functions are going to be, because the data will decide then what the functions ought to be. And I really need to set something up to indent everything in the style that I prefer rather than fighting with my editor to make it happen every time. We are going to do something very weird. We are going to have a pointer to a statement list. In fact, we're going to have a stack of pointers to statement lists. Means we have to forward declare statement list. Block stack. You know what I'm going to do? this is going to require there to be a special parse top, because parse context here is not going to, yeah. So yeah. Oh, the spammer returns. Parse top. So now we no longer have a special parse top function. Or we no longer, parse top stops being an alias here. Yeah, we're going to have an actual parse top. I probably should change all of these functions to be like this, but I won't do that just yet. Well, actually, I will do that just yet, because I'm going to have to be adding another parameter to all of them. Yep, that's what we're going to be doing. And parse top is going to be special here, because parse top isn't going to require a context. Its job is to create the context. That is its only job. Now, if I were using Emacs, I'd write a macro to do this. I'm tempted to just ask Junie to do it, but I think I should maybe have something that reduces the spam here, but this isn't a header, so I don't want to reduce the spam. Like that. Which means that boring editor task. Is there a way to, as I said, if this were Emacs, I'd be doing it as a macro. I don't want, I mean, I'm tempted to just pull up Emacs to do it as a macro, because that would be, you know, that would be what I would do normally. It's just that I don't necessarily want to pull up Emacs on stream, because my Emacs startup is going to do a whole big bunch of things, and it's kind of, yeah, just here. laboriously going through and doing each one of them. I don't know if this is any faster than me doing it or not. It certainly involves less typing on my part. Hello there, Adobe. We're letting an LLM do something that I would normally use an Emacs macro to do. It's way overkill, and the LLM is being slow about it. We're adding this context parameter to all this stuff. Yeah. All right. It did it, and it did it correctly, and simply recording an Emacs macro would have been faster. All right. So, one of the reasons I did this is because I wanted to keep the definition of what parse context was out of view of anybody using this. It's not part of the public interface. I put it in a priv underscore namespace on purpose. So no, not parse context, you silly thing. Like that. So that's what the parse context is. For now. There. Parse sequence. So what are we doing here? We're building a parser for a fairly simple language. That language is described here with this EBNF. But there's more to it than that. I've just added this var declaration, but this var declaration implies static scoping. And so I wanted to add static scoping. Right now, whenever an assignment statement is seen, and the var declaration is treated exactly the same way as an assignment statement right now. Whenever an assignment statement is seen, basically a global variable gets set. And that's that. There's just a global variable. There's no concept of scope at all. So I wanted to add this var declaration so that then when you referenced a variable, you knew you could create names that hid in smaller scopes that hid names in larger scopes. For example, here I could create a name called parse top. I could say int parse top. So now, instead of parse top referring to this, which is normally what it would refer to, parse top inside of this function here would refer to this integer. This name shadows this other name, and inside this function, this name has precedence. This is what static scoping is about. And so my program currently doesn't have that. Even if you say var parse top equals blah in something like this inside of a statement block here, it just assigns the global variable the value. It doesn't create a new parse top. And it needs to create a new parse top. So that's what this is about. And the context is keeping track of what scope I'm in. And so one of the things that this needs to do this class exists to do one thing. It exists. Also, this is going to be it's going to initialize the stack frame. It's going to basically push things onto the exists so that the constructor and destructor do this work. And we're going to make it, even though I'm not going to try to move it or anything, just out of general principles here. It's not copyable. copyable or movable. Comes into existence, can be deleted, and that's that. It'd be nice to disable new for it, but yeah. I mean, I could do this. Actually, I'm curious as to how that, what that results in when I do it. Because I just deleted operator new from something. Does that really do the thing I hope it does? Let's test it out here. All right. It does do it, I think it does. But I can do this. I can say, right, that works great. That, of course, is a terrible error. Um, but I can do it. But I can't do like that. That won't work. Hee hee. Alright, well, I just discovered a way to disable new for something. Now, is that the actual signature that new is supposed to have? Is it supposed to be returning a void pointer? I don't know. It doesn't matter in this particular case whether it's the correct. Stupid sea lion and its inability to handle focus follows mouse. All right then. We're going to rename this. We're going to call it not spec frame, we're going to call it here refactor rename. There, scope frame. There, now I don't have to do this anymore. Nor do I have to do that. And I can say scope frame Yep. That's exactly what I want. And then when the scope frame goes out of scope, it will automatically pop itself off the context. I can say bool and then say I have a rule about this. There. There. But why are you doing this? You know that's not what I want you to do. Right, that's what what I want you to do right there. Oh, that's the problem. There. 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 This is a lot easier to do here, partly because the IDD is doing half the work for me. And of course it's using an AI-based completion of some kind to do it. But it's doing the work for me. So that's nice. And doink. Doink. It was, the last time it was getting really confused because it was all a syntax error because I didn't put a comma there. The way it reacted to that confusion was very confusing and not at all helpful for telling me why it was confusing. It should have just, put my keystroke in instead of kind of reinterpreting my keystroke to mean something completely different. All right. Let's see what happens when I compile this and get a whole big bunch of errors. Because yes, this is not at all helpful. There, that's the problem is. There. Ooh. Now the question is what line is that, or what column is that on really? And if we go down here, that's still column 76. So all this stuff is ghost stuff. It doesn't really exist. It's the thing that's apparently pushing it beyond the end of the line here. So we're going to let these errors guide us to where we need to fix this to add like that. And in fact, okay. 64, 65, 67, 66. I'm looking at this number down here because I want to make sure that the actual line length, the real line length, doesn't go across. Basically, the line length, not including these ghosts here, doesn't go past 80. And so 69. 79. There we go. Error. 66. There we go. Go. That one is too long. There. And it's very helpfully finding all of the, highlighting them all in red for me. So I can go through and fix each of them. Again, just looking at the number down there to find out what the real column number is. Three. 63. There we go. Now let's try building it. Now, this context doesn't do anything. So all the test cases should still pass. In fact, there's nothing that I am going to do here. Well, no. There's something that I will do eventually that will cause all the test cases to break. And that something is, insisting that you declare a variable before you assign to it. That is something that will change. All right. So none of these things, interestingly, care about what's going on here. There's only two things that are going to be caring about this context thing. And it also means that I have to add something to the statement list. The statement list needs one more thing in it. Oh, it's already got it. What it has, though, is the wrong thing. Also, does this even get used? It's identified some of where it gets used. All of the usages of this are within Simple Evaluator. So I can change this at will and it just breaks Simple Evaluator, which Simple Evaluator is going to have to break anyway. I'm going to turn this into a bite-sized commit. All the tests pass, no functionality was added. Come on. I hit Control S. Once you hit Control S, that's the X off. Hit Control Q, that's X on. What do those mean? Have to go find out for yourself. But you can see start is Control Q and stop is Control S after the output of STTY here. And so the stop character is Control S and the start character is Control Q. There's an ancient reason for that. It goes back to the 60s. What these characters are can, of course, be redefined. You can use STTY to change them. Hardly anybody knows they exist. Those people who do know that they exist will be incredibly confused if you change them. Software that knows they exist will be incredibly confused if you change them. They are a holdover from inline control flow for RS-232 connections. They're actually encoded in the ASCII table. If you look in the ASCII table for the character value for Control S, here we'll oh, come on. There we go. 23 octal, 19 hex, or 19 decimal. So if you go to 13, go to 13 hex in the table. I don't know how to get, there we go, D1. So 19 decimal, 13 hex, 23 octal. That's the character value you're looking for. You'll discover that it's, well, actually, let's do it just as a digression, just because this kind of thing. Let's look for ASCII table. Oh, this is tiny. There. Decimal, 19, 13, 23. Device control 3. Device control 4. Oh, that's not exactly what I thought it was. These are widely treated as the X on, X off characters. Control Q is, of course, one after Control S. No, it's not. No. Control Q, QRS. QRS. So DC2, that's this one. Let's just, yeah, 21. So DC1. DC1 is Control Q, DC4 is Control S. DC4 is widely X on, or X, yes, X on? Yes, I think X on. And X off is here. Let's go look here. Let's ask Google. Ah yes, device control 3 is control S and device control 1 is control Q. There we go. X off, control S is X off, and DC1 is X on, widely used for software flow control. Basically for the remote side to say, hey, you got to slow down a bit, I can't keep up. And then, all right, you can continue inline control flow. So the terminal driver for Linux still supports them. So if you accidentally hit Control S, no more characters. Control Q, they all come back. Little tidbit that you never knew before. Anyway, now that we've gotten over the confusion, why did I go here? Oh yes, I was doing something with Mercurial. I still have not written the pre-commit hook. I should write this pre-commit hook. All right then. So where do we really care about this? First, we only care about this in variable declarations. We care about this in the statement list because the statement list is where we create a new static scope. Every statement list is a potential static scope. And then we also care about it in the variable declaration and everywhere where we see an identifier, because the identifier has to appear as a thing in the appropriate scope. Here is what we're going to do. I put an unordered map here because it needs to be an unordered map. Or it needed to be an unordered map for what we were doing. Or it didn't. In fact, I did it wrong. But I was using unordered sets for identifiers in general, or unordered maps. Here I didn't need a value, so I just used an unordered map. But that's not really what I want here. What I want is a whole set of structures defining the properties of the identifiers that are available in this scope. So what we are going to do is we're just going to have a standard vector of and nope, we're just going to have a vector of strings. Yep, of variable declarations. This will make this stop working, but that's okay. Here, in the variable declaration section, also identifier I'm not going to in any way refer to the which block this is for or anything like that for a number of different reasons. It's really easy to mess it up once you start doing that kind of stuff. Like this is going to be a pointer to something, it's going to be a raw pointer to something that may go away. It's going to be very confusing. So it's best to have the thing that uses this already know the context, and so it knows what statement list it should be looking this up in. So that's what we're going to do. And here, yep. And then the last one that needs to change is identifier. And oddly, identifier has to come after statement list, because all that's going to be in here is and we're not going to initialize the name. In fact, we don't care about the original token anymore. What we care about is the like that. Oh, Now I might add the token back in, information about the token back into here, because it would be nice for error handling for this thing to know this particular use of this identifier occurred in this particular spot in the code. Same for some of these other things here. In fact, you know what? We are just going to say yes. And we can define this here because, oh, we don't know, because AST pointer, we don't know. Here, the same thing. Not a token identifier, just an identifier. There. And we'll look down here for assignment statement for our declaral. And here it's not going to be this, it's just going to be identifier, not a const reference, just a plain old ID. Like that. And here also a plain old identifier, not even a const reference. I thought I fixed assignment statement to do this. Right? Okay. We are going to change this thing's name. No, Shift F6. It can no longer be identifier. It should be identifier instead. Which will change it down here. And here I'll be able to say like that. All right. Now we just have identifier as being a thing, which that's how it should be. We should just know that it's an identifier. All right. So then parse var decal. How does parse var decal? Parse while, parse var decal. How is that going to work? Why don't I parse identifier? Huh. This is interesting. That was a notification noise. How long have I been going for? I don't know. Here is a way to find out. So an hour and a half. Okay. I make an identifier node. And no, here is how identifier should work. And this will probably have to be, the constructor for it will probably have to be moved into nope. We are going to add a new parse function. Parse identifier is going to have to do a whole big bunch of fun work. There we go. we're going to have some logic here to do some lookups. So, my confusion here. I don't have functions yet. But I do have functions. What I want to do won't work. Because what I want to do is have kind of this global assignment of identifiers to an index. But once I have functions, that won't work, because as soon as you call the function, another context gets pushed onto the stack, right? And that context will have its own local variables, and their indexes won't be part of the global index thing. This works for a static scoping and global, because you enter a thing, you enter a block, bunch of variables get added to your list of variables. You leave the block, they get chopped off and removed. But functions are a little weird, because you can enter the block multiple times. While loop, you enter the block and you leave the block. Functions, you can enter the block, function can call itself and enter the block again while you're still in the block. And so you can't have a global index that works, because the variable's index into your list of all variables is going to depend on how many times you've entered the block. So functions are going to have to use a different system, or there's going to have to be something in the identifier that says what kind of place are we looking for this index. Is this index local variable index, or it is a global variable index, just like the Python bytecode does. And yeah, that is going to be interesting. So right now, all of them are global. I have no functions. This is not a problem. And so I can do this just fine. Now, what I'm doing with this context thing is, in fact, every statement list has its own thing, its own set of indexes. The global versus stack thing will still work, and so I can still do this. So here's going to be the lookup logic. Am I really calling it context every time? No. There. Does that work? I hope that works. What does find if do? Well, I don't need find if. I'm perfectly happy to do find. So what are we doing here? This is a pretty complicated bit. Yeah, this is a pretty complicated bit. So we're going back to our stack of statement lists, right? We're going back to our stack of declarations, starting at the very most recent, going all the way to the beginning. And then we're looking, does our variable identifier exist here? Also, yep, that's short enough. So all the ghost stuff, good. So does the variable, is it in this list? Right, because we're going back through all the blocks where we could have had variables declared. Right? A statement list is a block. We're going back through all the blocks in reverse order, going through their variable declarations, which are basically just strings, right? And the index is actually the sort of the index of the variable, and the string is the value. So we're basically, the identifier, and then the index also carries information, like we're referring to them by index. So we're going through all of the blocks. We're going through all the blocks in reverse order, and then we're looking through their variable declarations. Is our identifier in that variable declaration, in that block's list of variable declarations? That's what this is about. Because if it wasn't, then we go back, right? But if it was, basically this is the success case. If the failure case is if it is end. One of the things I could do is just have it say if it's end, continue. Indicating that that's a failure. But this is the success case here. It found it. Okay, well, IDLoc is an iterator, right? It's not an integer, and identifier is storing the index of the variable in this statement list. Right? The statement list variable index. So we need to convert it, but this is a vector. Just a bit. Let me pause the stream for... because I have something to do. Just a bit. I had someone coming over, so I wanted to, yes, a friend coming over for the. So back to the explanation, going backwards through the blocks, right? Then in each block we're looking, is our variable declared? So we're basically going into the most enclosing block, next, 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 the outermost block. Looking for our variable in each. So we're looking to find the innermost block in which we can find the variable declaration for our variable, for our identifier name. And if we can't, well, if we find it, what we do here is we look to discover the now distance is interesting. Ah, yes. Don't need to use distance because they're random iterators. They're random access iterators. Because they're, vector iterators, and so distance should actually short circuit to just being a minus. But that's okay. This will work even if I change it to not be a vector anymore for some bizarre reason or another. So this discovers the distance between these two iterators, which is the index, and it returns that distance as a pointer diff_t as a signed value. And so I have to cast it to the unsigned value. And here, what I should do here is assert that, right? Because that should always be true. Like, that must always be true, given the way this program is structured right now. But, it's always good to check an assumption. And since we have that assert there, then this won't result in the variable being chopped off. Like, converting it to unsigned is just fine. I wish there was well, no, it wouldn't be. Okay, we won't get into that right now. So, when we do find it, we create an index for it, an integer representing where it is in the list, and the identifier is given that integer. So identifiers are inherently related to the context in which they appear. And so that context is very fragile. Whenever an identifier node is seen, going up the tree to find the statement list that's up the tree from it is going to tell you, what index. Oh, this is a problem, because I'm not storing which statement list I got it from. I have to store which statement list I got it from. I have to do that. Oh, it's so ugly. So ugly. Because this is a non-owning pointer. Yeah, it's a non-owning pointer. Fortunately, an identifier will always end up being owned by the statement list indirectly. There'll always be like a chain of ownership leading from the statement list down to the identifier node that refers back up to it. So if the statement list is deleted, it will delete everything that's pointing. It'll delete all of its children, which will result in deleting the thing that points back up at it before it itself goes away. So this shouldn't result in any dangling pointers, but reasoning about that, oh my, that's tricky. So because this index is irrelevant without knowing what scope the index refers to. Sadly. So there we go. And here, so there's the scope. And this is column 79, so it's still within bounds. That's good. Next. Okay, this is right. Then if after going up through all the scopes up to the very top scope, we still weren't able to find the identifier, then we're going to complain that the identifier wasn't found and fail the parse. I'm going to go through and put to-dos in all of these spots here. I'm putting these in here because I'm going to be ending the stream and I want to remember what I need to do next. Now, good. That's all the places where we care about an identifier token, and we're going to be changing them to parse identifier, except here inside of parse identifier itself. That's right. Good. Interestingly enough, in var decal, if we were successfully able to parse an identifier, then it's a failure. Because that means we're redeclaring an already existing variable, except, yeah, that's not the right thing to do. And I'm not, I'm going to leave this to do in here just to as a reminder, but this is not in fact, yeah, I'm not going to use parse identifier here to try and identify whether that's in the statement list variable declarations. In this case, I only care about the most enclosed statement list. Like the most recent statement list. And if it's not in the most recent statement list, we're not redeclaring a variable inside of the same scope. And so it's okay, because that's the thing we're checking for. If we're redeclaring a variable that's in fact declared in an outer scope, that's just fine. And so using parse identifier to actually search through the scopes is not appropriate. I should just be searching through the most recent statement list, the most innermost statement lists variable declarations. That looks good. Okay. So, with all of that in there now, as reminding myself what to do next time, I am going to end the stream. I wish somebody had asked some questions. I see that we just had Kessie Jones show up not too long ago. Been here for a whole 12 minutes. Do you have any questions before I end the stream about what's going on? I should be back Saturday or Sunday, like around 2 or 3 p.m. Pacific Standard Time. Not sure whether it'll be Saturday or Sunday yet, sadly, but one of those 2 days, and I'll be finishing this up. Hi there. Anything you're curious about before I end the stream? Questions? Stuff you want to know? All right. Well, I hope to see you again at some point in time. I'm building myself a toy language here just because I've never, in fact, really built a serious parser. And I just added static scoping to it, and I'm implementing that, and it's turning out to be interestingly tricky. Um, I think I'll actually add functions to it eventually as well, which will complicate things even further. Um, all done in C++. So, anyway, I hope that you have a good rest of your evening. Poof! I got big.